My name is Stephen Laws and I'm here to talk to you about my research on robots for orthopaedic surgery. For a successful surgery, a robot needs to know its location relative to the patient, allowing it to operate accurately. The conventional approach is to track the rigid bones of a patient using embedded optical markers. These markers have a risk of causing bone fracture, coming loose, and in some cases causing infection. Currently, only the bones of a patient can be tracked, not the soft tissues around the bones. During my PhD, I noticed that the specular pattern around where a laser pointer intersects a material is correlated to the material type. I did a study classifying cadaveric tissue using only pixel information around a laser spot using a convolutional neural network and achieved classification accuracy of over 95%. This classification technique has since been patented and published in a journal. Extrapolating from classifying a single point, I hypothesized that it is possible to classify hundreds or thousands of dots in a scene using the same technique. Projecting a multitude of dots onto a scene can also be used to calculate depth information using structured light techniques. Thus, my research could allow simultaneous classification and depth measurement within a scene. This would allow surgical robots to actually track bones and soft tissues intraoperatively and in real time. Alongside my vision research, I have been lead developer on a prototype for a small, back-drivable haptic orthopaedic robot, which started as part of my master's project and has since become part of a startup called Signature Robot Limited. The current prototype is small, lightweight, costs a fraction of commercial orthopaedic robots, and can allow pseudo-haptic control. I plan to integrate my vision system with this prototype to allow the robot to see its environment and change the haptic response accordingly. For example, when close to a certain material, the robot can become stiffer, slowing the motion of a surgeon, and softer for a different material. Thank you for listening.